I'm going to put my microphone on mute.
Looks like we still have a couple minutes.
Hi everyone, Suzanne here.
Hey Suzanne, how are you doing?
I'm good, thanks. How are you?
Great. So we will get started in a few moments here. We're just waiting for other people to get on the call. And then I think Patrick and Jonathan Darton will give a few introductions here.
Okay, perfect.
If you're just joining the call, we'll start in a few moments here. We're just waiting for more people to get on the call, and we'll start shortly.
Sure.
What do you think, Patrick? Should we get started?
Sorry, John, I was on mute. Yeah, I think we probably should at this point, yeah.
Sounds good. Did you want to start off with an introduction for the ATIS committee, and I can follow with ATMS?
Yeah, for sure, yeah. Okay, good morning, everyone, and thanks for joining us on this Friday morning. And welcome to this joint ATMS ATIS webinar, Traditional versus New Models for Traffic Management. We're just going to start off with quick introductions. My name is Patrick Fitzhenry, and I'm chair of the ATIS committee. Co-chair is Judy Yu. We're basically working with the ATMS committee here to host this joint webinar. It's worth noting that I'm at the end of my time as chair of the ATIS committee, and will be stepping down in September, where Judy will be taking over. So if there's anyone with interest in being the co-chair of this committee, please have a think about it and connect with Judy and I with an expression of interest. We'd love to hear from you. John, do you want to talk about the ATMS before we go on?
Yeah, sure. Just quickly. So just to add to Patrick's comments, again, the session's been organized by the ATIS and ATMS technical committees. On the ATMS side, the committee consists of mostly public and private sector members interested in ITS and traffic management. The group often gets together and shares lessons learned and industry best practices related to ITS implementations and operations. We meet around every 2 months to share information and also coordinate sessions like the one today. So if you're interested in joining and participating, feel free to reach out to Yannicka from ITS Canada. Everybody knows Yannicka, I'm sure. Or myself, Jonathan Darton, or co-chair Jonathan Ford from the City of Winnipeg as well. And that's it. Thank you.
And you don't have to be named Jonathan if you want to join the ATMS technical committee. We more than welcome other names.
You don't have to be, but I suppose the other thing is we've got a couple of other webinars planned in the next couple of months, so there'll be notification coming out in relation to those in the very near future. So thanks very much. We've got a great attendance this morning for this. So without further ado, we'll just talk a little bit about what you can expect this morning. So the first presentation will be from the City of Ottawa, and the presenters will provide an overview of the history of traffic management in the city, new innovation and work being done in the connected and autonomous vehicle space, and a discussion on the impact new technologies may have on a city operation. Next, then we'll have transportation management as a service, which is about creating the TMC of the future, which is cloud-based, integrating local and global information sources, and providing information understanding to local authorities and individuals according to their needs and preferences without significant investment of building, staffing, and hardware of traditional physical traffic management centers. And Suzanne and Marius will present on that one. And now, as we go into the City of Ottawa, our two presenters are Greg Kent and Omar Chowdhury, and I apologize if I'm pronouncing your name wrong, Omar. So Greg first. Greg is a professional engineer with 30+ years of experience working in the field of traffic and transport engineering. After graduating from Carleton University, he started his career with Delcan Corporation in 1987 as a junior engineer, then switched over to the municipal world in '89. He's worked his way up through various roles and responsibilities, covering everything from traffic impact studies to transportation modeling to road safety programs to traffic management. He's currently the manager of the city's traffic management branch, overseeing, amongst other things, traveler information systems, incident management systems, and CAV research and development projects. And he's joined this morning with Omar, and Omar is a registered professional engineer, has been developing and implementing technology solutions for over 20 years now. He's worked extensively on projects across the United States and Canada, covering the entire range of applications from development of system architecture to electronic collection systems design, and from data integration to deployment of information management systems. Omar spent 10 years working in the United States before returning to civilization in Ottawa to run an ITS consulting company and later launching a tech startup in the gig economy that employed nearly 80 staff. This past November, Omar joined the City of Ottawa as project lead for transportation system management. So please, folks, take it over. Thank you.
Just one more thing before we start there. So in terms of how we'll coordinate questions, if you do have questions, please put it into the box on the side there. I will take those questions, and then once Ottawa is done, we'll have 10 minutes for questions for Ottawa, and then we'll move into traffic management as a service, which will have 10 more minutes for questions. And then if we have time at the end, we can open it up for more. So go ahead, please.
All right. Perfect. So I think hopefully everybody can hear me. So this is Omar Chowdhury. I'll let Greg introduce himself so you can hear his voice.
Right. Thanks, everyone, and glad you guys could join us. And we're glad to have the opportunity to basically pass on the information that we have here at the City of Ottawa. Omar is going to lead the presentation for the most part, and I'll jump in on occasion.
Perfect. Thanks. So talking about TMCs and connected vehicles here in the City of Ottawa, just to give a little bit of context, you here on the map, you can see the City of Ottawa. If you can see my mouse, hopefully, the core of the city is located here with the green belt and then a larger area. What you see on the map is our traffic management coordinator or inspector areas. And the large majority of the city is actually rural, as much as you don't expect that. We have about 1 million people in population, significant employment, of course. And more recently, you may have heard BlackBerry QNX, along with the federal government, announcing $350 million of funding over the next 10 years to further pursue their connected vehicle initiative with 800 new jobs. Ford Motor Company is here located in the city with about 300 of their connected vehicle employees and expanding with another 400. As well as a number of different startups working both on the infrastructure side as well as on the technology side of things. So just as a side of things, here's a picture of our traffic control center. It's changed a little bit since I first visited back in 1993 as a university student from Carleton. But it looks, similar to what most traffic control centers look like. From a operation side of things, we handle daily traffic monitoring. Being the nation's capital, we have some unique things like presidential visits as well. And that obviously has a greater impact on routes, what roads are available or open and so forth, as well as we're in the snow belt. We get a lot of snow, construction incidents. The Highway 417 is managed by Ministry of Transportation of Ontario, MTO. So there needs to be a close interaction when roads are closed or when the 417 is closed. In addition, we have what some people may consider or have a semblance of a, of a sports team, a hockey team that operates out of the Canadian Tire Centre, as well as a football team at TD Place. So for our computerized traffic system, it started in 1976, a Honeywell system. Had an upgrade in the 80s, and then in the 90s, actually, things started to be built and developed in-house. That obviously has a number of different impacts and advantages. One of the things is that as a city, we have complete control over all the hardware and software. So we are able to make incremental updates to the software, as well as integrating and testing some new features, and I'll talk about that in just a minute. As a network, we have approximately 1,200 traffic signals. 100% of them, all of them are online, communicating in real time back to what we casually call Loretta, which is where the traffic management and traffic control center is located. We use a combination of wired and wireless. Some of it is our own fiber. Other of it is through the telcos. And over the last number of years, there's been a push towards getting pedestrian countdown timers, as well as audibles at the signals. And overall, we have about 241 cameras. 3 of them are mobile units, which we can deploy and do deploy when there are special events, such as hockey games and certain nights at the Canadian Tire Centre. Operationally, certainly as many of you who are in the industry know, the coordination of signals allows us to help reduce delay, improve congestion, reduce fuel use, and so forth. Because of our system, we're able to identify any faults and dispatch crews as necessary to the traffic signals as required, as well as providing incident detection and data collection. The more interesting thing about what we've been able to do is with the system, our staff are able to override and change traffic signal timing plans, and usually those transitions happen in around about 100 seconds. As a little bit of a teaser for anyone who hopefully will be either coming to CITE in June here in Ottawa, or going to be at ITS Canada, the TAC and ITS Canada joint conference in September in Halifax. We hope that to be able to have some additional presentations, because right now we're working on and just launched or started testing in February, was investigating how we could use artificial intelligence to actually dynamically select timing plans based on the traffic conditions coming into specific key corridors. The information I'm being told is it looks promising, so stay tuned and look forward to that. But obviously, the investigating and being able to implement things like AI leads nicely into talking about some of the future technologies that are coming, and I'll turn that over to Greg.
All right, thanks, Omar. So just to add on to what Omar had indicated, we're now looking at future technologies, and we're in a great position in Ottawa, given the high-tech industry here and the availability of 5G and all the other technologies that are coming, and we're looking to how can we plug into this. So we're looking at opportunities, and we're always trying to improve how we operate our traffic control signals, and the structure and the program and the system we put together has allowed us to do a lot of things. And moving into connected vehicles, we see greater opportunities there as well. So we did initiate some work recently in the connected vehicle realm. And you might ask, why are CAVs a key for the future? Well, we know there's benefits, safety benefits, particularly mobility, and the environment for certainly a reduction of harmful emissions. So those are sort of the three pillars that we're working from. And we see we can get a net benefit in all the areas. And working with our traffic signal systems, we really were focusing on the environment and the mobility piece at this time. So we initiated one of our first projects, and this was an opportunity that presented itself from MTO and Transport Canada. It was referred to as an eco drive. The focus really was to eliminate harmful emission and bring down the cost associated with fuel use. So this project was referred to Eco Drive 1, I2V, Infrastructure to Vehicle Connected Project. I've presented on this before, so some of this might be a repetition for some, but just providing an overview, basically took our signal timing information and was able to pass it on to traveling vehicles on a road corridor so that they could drive in a more effective and efficient manner. They were able to get green light optimal speed advisory information so they could try to hit the green more often than not. And that was all based on an FHWA glide path initiative that was conducted in the early I think it was around 2014 that they undertook that work. So it was all based on cellular communication, not DSRC. That gives us more flexibility, and we didn't necessarily need the accuracy of DSRC to do what we were doing. And we undertook that project in 2017. So really the focus, as I'd mentioned, was to give the information to the driver, and the driver would pick it up. And based on the situation, they would approach the signal differently. So there's sort of four scenarios, as noted on the screen there, in which they would approach that signal. And sometimes you'd have value in providing the information, and sometimes you wouldn't. So just a quick overview. The Eco Drive project, it was in a corridor that was basically 6 kilometers long, Hunt Club Drive was the road. It connects the 417 in the east and the 416 in the west. So it's really our major east-west arterial through the bottom part of the core area of the city, just inside the Greenbelt. The project itself had 12 signals. They range from 200 meters to 1.2 kilometers apart. And the speeds on the road were 60 kilometers to 80 kilometers. Trucks represented about 4%, and our target for EcoDrive 1 was goods movement vehicles. So that's where we thought we'd get the most efficiency in terms of fuel reduction and emission reduction. So the information that was passed on to the drivers came in on a tablet. Basically, it represented the 4 scenarios that could occur, and it would tell the driver the information that they would need to know to either slow down or adjust their speed or drive a recommended speed to more often hit the green, or to slow down if they're going to hit a red where they didn't have to brake as hard. So overall, the results were mixed, but for overall they were positive. They basically gave fuel reductions, emission reductions, depending what type of vehicles we used. The commercial vehicles that we applied in the project were 5 per liter vans, 1 Creppen, which was a hauler that we have here in Ottawa. We used a dump truck, and we put different loads in that dump truck to represent different conditions of vehicles traveling on the road. And then Carleton University had the research van. So we did this project in cooperation, in partnership with Carleton University as a research group and industry partners that provided the technology to take the signal timing and basically predict what the signals were going to be, because we were in an actuated signal situation, and push it out to the vehicles. So those were our partners. So overall, we had some positive results. There's certainly room for sort of advantages to using this type of a system. We did know that there were some limitations, though, as well. When there was congestion and the speeds were low, you really weren't able to utilize the information that was being passed on to the driver. So what does this mean? Just sort of put things in perspective. Our city fleet uses 11 million liters of fuel in a year. So if you trim that down by 5 to 10%, there's a significant savings to it.
So, I guess, and the result of that project sort of took us to the next project, which is EcoDrive 2. Hey, if you have one, you might as well have 2, right? So that's part of the ATIS programs funded by Transport Canada, which is the Advanced Connectivity and Automation in the Transportation System. And so we're just in the process, and part of the impetus of me joining back in November was to make sure and help to get this project going. And so we're actually in the process, hopefully just after Easter, we will begin testing for 2 months with a 2-week on, 2-week off sort of protocol for 2 months. So that way we'll end before the summer season begins, enable us to do some computations and calculations and analysis of the data over the summer. We're going to be increasing the number of vehicles. Right now we're looking at 10 vehicles. All of it will be city staff and city fleet with a wider range of traffic conditions and signal spacing. We're also in-house building an Android app, so as opposed to the tablet, which was used in more for in the format of research, we're going to actually be building an Android app. It will log all the data right now in a CSV format on the phone, location, the engine performance, so the amount of fuel used, hard stops and rapid accelerations. As well as the information will be more optimized for easier display, if just to reduce driver distraction. So what does that mean? If you can see on the map here, there's a series of greenish sort of traffic lights. That was the signals that were used in EcoDrive 1. So for EcoDrive 2, every single traffic light that you see on this map is actually going to be connected. So we're expanding to the entire 1200 signal system, which will allow us to almost anywhere our city inspectors and traffic count installers travel. They will be able to be collecting data for us. And before I continue on, I'd like to just sort of highlight two locations. There's a blue box. It doesn't show up maybe very well on the screen. I'll talk about that in a second, but I'm going to first talk about this purple one down here closer to the green dots. So a few years ago, an opportunity came up where the NCC had some unused agricultural research labs in the suburbs, just south of our location here, our offices here. And it's about 1,800 acres of farmland, 16 kilometers worth of roads, some buildings, and so forth. And in the future, you can see up on the northern part there's a community of buildings and roads. On the southern part, the plan is to eventually have a high-speed test track oval to enable sort of more of the freeway kind of testing and so forth. But essentially, it's run and managed through Invest Ottawa, which is our entrepreneurship and startup incubator and accelerator here in town. And so they have been in the process of reaching out to auto manufacturers, tech companies, and others who may want to come in to Ottawa for development and testing of autonomous vehicles. Now, this whole facility is access controlled and private, so there's no interactions or engagement with normal traffic. And if things work out here, I'll give you a little overview of the environment. All right, so that gives you a little bit of a context as to the size and the location. Just as a little fit up, so we have both four-way as well as three-way traffic lights. We have bike lanes, four-way stops, three-way stops, parking area, as well as some one-way roads and a pedestrian crossing. The entire environment is closed. We will be having, I guess what I'll say, 5G devices or network, private 5G network that's actually coming directly from the research labs at Nokia and Ericsson to be able to set things up at this location as well. So hopefully, if you do come in to visit us here. Oh yeah. So since that video, a lot of the infrastructure has been put in there. So you can see we just take some pictures here of some of the staff having put up the traffic lights, painting the lines. Everything is basically ready to go for testing and so forth. The roads are also plowed. So winter road conditions and so forth can also be a test. The other location that I mentioned, the blue area, is actually on-street live traffic environment. Right now, the area in yellow or the roads in yellow are the original or the first set of phase. We will be implementing the rest of the roads. So this is in our Canada North Business Park. So this is where a lot of the tech companies, BlackBerry, Nokia, Ericsson, Alcatel-Lucent, and others are located. And so with that, we will be implementing our first smart intersection. That intersection will be equipped with everything from Bluetooth, video, radar detectors, acoustic detectors, pavement and weather sensors as well. It'll have a combination of DSRC, 5G, 4G, LTE, as well as 915 megahertz radio frequency devices. And the concept basically, in order today for you to be able to build a smart intersection, you need to set up map and SPAT data. So map data, just as a high level, is the geometry of each intersection. It allows you to identify each lane, the ingress, the ingress and egress, what lane connects with which lane, and you identify bikes, pedestrian crossings, and everything like that. So there is a significant amount of work and effort to be able to identify and draw up the intersections. But in addition to that, then, so that's the static data. Now, static is also relative. In the downtown core, for example, we have lanes that become parking lanes during off-peak. That information also needs to be into your map and map data to be able to allow the vehicles to know what lanes they can and cannot travel in. And then there's the SPAT data, which is the signal, phase, and timing. So that's really more the operational status of the intersection. And some of the information will be communicated back and forth, but essentially it's providing answers to questions like, am I allowed to turn left on red? What speed can I travel through the intersection? How much time is there left on green or red through that intersection? So what are some of the implications and opportunities for the city? As I mentioned, it takes some time to collect and to harmonize all of that data. So when we at the city start thinking of it, we've got 1,200 intersections. Each one of those intersections has to be continuously maintained, the information managed. On an annual basis, we have about 750 permitted special events. So these may be marathons, marches, demonstrations, parades, whatever they may be. That information right now isn't in a dynamic way provided to any system that could then report that information out to the vehicle to say, normally on Wednesday afternoon, you'd be able to travel here, but there's a parade or there's a marathon today and you won't be able to travel on this road, so take an alternate route. We also have more than 1,000 utility construction related events, and these could be any from new building constructions, the emergency road and sewers events and so forth. And all of that information, again, isn't in a real-time basis provided and collected and aggregated back through. So in addition to that, when then you start looking at all of the parking information, changes in signage, bylaws, maybe it might be no more of a right turn on red. As soon as that sign goes up and that restriction is there, that information needs to be dynamically updated and provided through if we're in a true connected smart city. So when we start looking at what are really the efforts to manage all of this data in real time, and then from the legal standpoint, what's the liability of providing that information, and if that information is not updated? So these are some of the things that we have to start to think about and consider. When we look at the opportunities for the city, when Greg decides to get in his car and say, okay, take me home, in theory, we'd actually have in real time origin destination information. So we could know every vehicle, where it's heading in real time. We know the location of the vehicle as it stands now. In theory, we could start getting towards where we're doing actually network-based route optimization and signal timing. And that's really kind of you start thinking of it, will we be moving towards, some people may talk about mobility as a service. Is it maybe a travel data as a service? Will the cities need to provide all the front-end infrastructure, in-field infrastructure, or will they be able to just provide data as a service? These are some of the questions that you start asking yourself. Obviously, the benefits are better capacity utilization, reduction in collisions, and cleaner environment. But we'd also be able to, in theory, collect better data, more data, real-time data, and be able to use that for city planning purposes. Two little things I'll throw out as a kind of things that make me go, when we start looking at here in the city, we have winter snow removal, towing for illegally parked cars and so forth. Is it possible that we actually get to a point where we don't actually need to do that because the infrastructure could actually just ask the CAV to move? Just as we start to think. And some of you may have seen or heard Tesla talking about back in December about how their new autopilot will actually be able to handle traffic lights and roundabouts soon. If you Google Tesla stops at a red light, you'll see some videos of older generations that actually just drive through the red light if there's no vehicle in front of it, and newer models that actually will stop at the red light. So one of the questions you have to start thinking of is this going to be a vehicle technology-led change or shift in the industry, or is it going to be more of an infrastructure tech-led? So with that, I'll turn it over to questions, and thanks for listening.
All right, thank you very much, Omar and Greg. Looks like there's a lot of exciting things going on in Ottawa. You guys have big plans, it seems. It's great to see. So if anybody has questions, feel free to put them into the question box on the side here. We'll go through about 10 minutes of questions, or as we have questions available, and we'll ask that of Greg and Omar. And then we'll move on to Suzanne. But if you have questions that come up, hopefully we can get back to them afterwards. A few questions that came up just really quickly. The overall presentation, this webinar is being recorded right now. And so we do expect to have this recording provided on our website at ITS Canada. So that will be provided after this is all done. So you can get that there. And perhaps we can follow up with Omar to see where the YouTube link is for the video that they showed on their item with the test track. So there was another question there from Campbell Scientific asking about contribution partners. Looks like you have quite a few. Campbell Scientific was interested to see if they could maybe contribute to your wind sensor there. So, I can leave that up between the two of you to discuss further, if that makes sense. But we'll get into some further questions about this. They're wondering about the test center and whether there are environmental sensors embedded there as well. Does the MTO use this facility for testing, or could they?
Greg, you want to take it, or?
Sorry, can you just repeat that question?
Yeah, so about the test center, they're wondering if environmental sensors have been embedded there as well, or is it just at the intersections?
The equipment that's brought forward by the startups or the OEMs that have this type of technology, we're applying it both in the Greenbelt Research Farm test track as well as the Canada North Research Test Track facility. So both locations, we're trying to get that technology, and for the most part, it's already been started to be applied.
Yeah, just to add to that, so the Greenbelt Test Facility, the off-track or private access controlled site, is managed by Invest Ottawa, and we can provide a link if you after the call. But if you Google Invest Ottawa and look for AVIN, or L5, which is their new program that they're just about to launch, standing for Level 5 autonomous vehicles. they actually are doing the coordination for getting startups and others into the facility there. So they would be the best person to talk to, but we can certainly help to help that discussion along.
Okay. And if you want there, Omar, if you have time later, you could always add the web links in the chat there for other people that are on the call, and they can grab that.
Oh yeah, for sure. I can do that, yeah.
Even the YouTube link that you shared there, that'd be great. Anything that's web accessible. Sajad asked, how does the new data produced fit into your day-to-day traffic operations? And I would expand that a little bit further and say, in terms of the stuff that you're building right now, as you put stuff in, there's probably things that you're gaining from that in terms of your day-to-day operations. Can you talk a little bit more about the benefits you're already seeing?
Sure. At this point, the research that we've done with the EcoDrive project is really grassroots development and research. So it's getting a sense of what we can and can't do, overall what the potential is of the system. So the data isn't really being fed back into our system at this point from those projects. The AI project that we're doing now is also research. We're still trying to figure out what we can do and what the abilities are and the benefits are. So that type of information is being applied, but more in a research point of view. And we're looking to see how we can make use of it in the future, but we're not quite there yet.
Okay. So Hal Mardani asked, is there any role for simulation to be used for design or management or control in real time? Or is it trying to automate that moving forward?
Simulation, I'm not too sure what he was referring to in terms of simulation, but the intent is to try to do everything in real time, not necessarily to simulate anything at this point, but there's certainly opportunity to look at simulation. I know the research work that Carleton is doing as part of this project, they're our partners, where we're missing gaps in data in our projects. There is certainly some modeling and simulation going on to identify, fully what's happening during the trials that we're doing.
Great.
And I think I just add to that, like it just, the coming from the tech world for a number of years as well. The technology and the capability of the smartphones nowadays, and more recently with Android Auto and Apple CarPlay, the ability to actually have apps and build apps and implement them in the vehicles is kind of, I guess I'll say, a game changer, really. It's taking the power of the mini computer that we all carry around now. It knows where you are. It can tell you, with it through the GPS, I can tell whether I connected to the vehicle or not, how far it's going, which direction it's traveling, and all those kind of things. So, where this all goes and what could be done with these units and the technology is, I think, quite exciting.
And there's a couple questions about collecting the data and how that data aggregation and management will be handled. Obviously, this is a huge question because we're getting more and more data that we want to make available to more and more people. But are you guys looking at any standardization technologies to house that? Any further comments?
I think that's probably the biggest challenge. And as I mentioned earlier, the traffic data as a service kind of thing, having it's really going to be a question of, who leads the initiatives. And the city does have a lot of information. Some of it may be traditionally, I don't want to call it siloed, but different groups, different departments and so forth are doing different things. Not everything is collected, aggregated, and in real time provided back to a central location. But that's probably the next big effort, I think, is to figure out how to collect and manage all the data that we are getting.
So going through the EcoDrive 2 project, we're certainly going to be collecting a lot of information, second by second data as the 5 to 10 vehicles travel around the network for basically a 2-month period. So yes, lots of information. That's why we have Carleton on board. They're doing all the crunching of the data. We will synthesize it to a point. We're using GIS applications to do that, but this is all part of the research. What does it take to manage this amount of data? What do you need for computing power devices? So we're learning, and we will report on that as we conduct the study and draw our summary conclusions.
Yeah, and just as a kind of go back to a note, like at this stage for EcoDrive 2, the data is being collected on the phone, and then at the end of the day, being sent back in CSV format via email to central location. But the potential of actually having that in real time, passing that information back somewhere is there. And that's, I think, probably where, the next stage is. I've jokingly, and Greg had the idea originally of, wouldn't it be cool if we could actually have a bicyclist be able to know when that signal is going to turn and how quickly. So, in theory, an audio response back as opposed to a visual display on the phone could be made available, and told the bicyclist, you better pedal faster if you want to make the green, could be there.
So one last question there, and just to make a note, I will put an email address if you do have further questions that we aren't able to address for the panelists or for the presenters, so that we can get answers after the fact. So that's a way to go. So that just look at the chat. I shall provide it there. Just one more question before we move on to our next presenters, which sound right up line with traffic management and services. What was the most important lesson you've learned to date in this project, and really what has most surprised you?
Okay, well, maybe we'll both have a go at this. So most important lesson is, I think the project was a pilot. Can we do it? Can we get a signal information from an actuated signal system for the most part? It's certainly easier to do on a fixed time system where you always know exactly what's going to happen, but in an actuated system where the signal timings are changing around depending on what the demands are, can you actually get meaningful information from the signal system, pass it to a vehicle in a way that's useful for their driving? So what do we learn? We learned that we can actually do this. Is there efficiencies in the way we do it? Absolutely, and that's what we've taken EcoDrive 2 on. And aside from expanding it to all the traffic signals in Ottawa and moving it into our fleet, there's a whole bunch of little pieces that we can improve on as we go in terms of how we present the information to the driver, how quickly it's presented to the driver, how do we capture it, how do we present it, the interface with the driver. Eventually, they would be automated, and the information would go to the car, and the car would decide how to drive. But that's down the road, and there's going to be a lot of advantages to these systems, whether we apply it to snow plows in the dead of night when they don't have to stop at red lights, or transit in off-peak hours when they don't have to stop at red lights. There's a whole host of advantages we can start to see, knowing that we can actually do this communication between the signal systems and the vehicles in a meaningful way.
Yeah, and I think I'd say sort of like, taking that to the next step is if as a user with my phone, I can receive the information about what the signal is it possible then for in enough real time to be able to provide that information back? So while I'm a regular driver, but maybe it's emergency vehicles for signal preemption, to be able to provide that information from a access controlled protected device. But then going back to the collecting information on the origin destination information, when Greg gets into his autonomous vehicle and says, take me home, there's obviously, with all the data issues and so forth, privacy concerns, anonymous, how do you make sure that information is protected in that sort of way, and then be able to aggregate that and be able to use that. I think there's a tremendous amount of potential. There's so many the Internet of Things, the IoT sort of play. There's so many devices out there collecting information. It's a matter of how can you best use it and make sense of it.
Perfect. Thank you, guys. So now I'll pass it over to Patrick, who can introduce our next speaker. And as I wrote, if you want to send questions after the webinar that we haven't been able to address, we'll try and coordinate those activities. But Patrick, I'll pass it over to you. And thank you very much, Omar and Greg.
Thanks, John.
Thank you so much.
Yeah, thanks, guys. That was really excellent. So as we move on to the second presentation, traffic management as service is about creating the TMC of the future. So our two presenters on this one are Suzanne Hendrikse, and I apologize in advance, Suzanne, if I got that surname correct. But Suzanne is an independent communications consultant and graphic designer from Ghent, Belgium, with a Master's Science degree in Product Design Engineering at Delft University of Technology. Suzanne approaches project communication from a design thinking viewpoint. Suzanne's job for the Traffic Management as Service project is to manage all communications and to ensure that the project experiences and findings are shared with the worldwide community of ITS professionals and stakeholders in the small to medium-sized cities. She's joined by Marcus. And Marcus is the Director of the Sourcing Operations Division of TomTom North America, based in Lebanon, New Hampshire. TomTom is a global location technology specialist that shapes mobility and an autonomous future with navigation software, real-time maps, traffic services. After various project management roles in Europe, Marius joined mapping pioneer TomTom in Ghent in 2007, excited by the company's propulsion of mapping solutions to a global audience. His bold management style quickly led to an international appointment in Southern Africa and North America consecutively. With more than a decade of experience in the mapping industry, ranging from leading large-scale software engineering programs to leading operational teams, Marius has a firm understanding of the mapping industry. The challenge is not building the map, but rather change detection and updating the existing map. He's passionate about the role that a company such as TomTom can play in projects such as Vision Zero and the building of a national address database in the United States. So I'll just hand it over to Suzanne, and thanks, folks. I'm looking forward to this.
Well, thank you very much. Good morning, everyone. Thank you for introducing us, and thank you for having us. It's great to be able to present our project from such a distance. So hello from Belgium, and can everybody see my screen? Yes.
Yes. Yep. Looks like you're good to go.
Okay, great. Right, so I'm going to show you our project, Traffic Management as a Service, that is very much linked with the services that were described by the previous presenter. So I was listening in awe, and I was really amazed by the pictures and the videos that you were showing. So what we're aiming to do here in Ghent is to develop a neutral traffic management framework for urban mobility. And this is a project that we are, right, yes, this project is conducted by the City of Ghent in partnership with a number of organizations, starting with two global intelligence mobility service providers, TomTom and B-Mobile, and also a software development company specialized in Internet of Things solutions from Ghent. Two leading universities from Belgium, which are Ghent University and KU Leuven. An NGO representing the interests of the civil society, and myself as a communications consultant. So this project is co-financed by the European Regional and Development Fund through the Urban Innovative Actions Initiative. And this initiative supports cities in Europe to experiment with new technologies. And so we're very lucky to be part of their program. You might have heard about us through the article that recently was published in Traffic Technology International. So where are we? We're here, the red dot, and the Belgium is on the map here. And well, for those of you who are familiar with our small country, you might know that Ghent is close to Brussels. It's the capital of East Flanders region. We have approximately 260,000 inhabitants, and it's it's a smaller area than the city of Ottawa, as you can see. We've experienced quite some growth, organic growth, over the last 10 years, which led to a number of mobility challenges that we have tackled and that we are still working on to improve. The first one was by introducing a parking plan to overcome parking problems, where we are guiding visitors to off-street parking through pricing, so basically by putting the prices up, and by reserving parts of the city for our citizens, and have a special pricing plan just for the citizens. So, and we also are trying to stimulate people to use public transport wherever we can. We implemented this project in 2016. You might have heard from the circulation plan that was implemented in Ghent in April 2017, where we basically launched a plan where in one night we changed the city dramatically by preventing going through the city. If you wanted to be in the city, you could normally go through the city and leave the city again. Basically, by implementing the circulation plan, you cannot do that anymore. So you have 6 sections now, and you can only go in and out of the city in that section. If you want to go from one section to the other one, you have to first get back onto the ring road and then enter a new section. So the ultimate goal of the circulation plan was to unburden the city from ongoing traffic. And the result of this project was that whoever needs to be in the city will get there easier. So I'd like to introduce the reason why we actually are talking about traffic management as a service today. So we, as the City of Ghent, identified that the current ITS offers that are on the market are very much transport oriented and car oriented, whereas the cities, the small to medium sized cities, have a view of well, more than just transport and cars, and they also are in need of a more multimodal approach. And we identified that the current solutions are not always tailored to these needs of the smaller cities. Apart from that, when you're talking about a small city like ours, the scale is very different, and also the manpower that we have to do traffic management is more limited than, let's say, the mega cities. Our budgets are smaller, and there's also a very diverse range of problems that cities like ours run into, and so basically this generates a context where you would need a service that would be very flexible and adaptable to a city needs. So for the City of Ghent, we started with a few pilot projects a few years ago, where we built a dashboard to just start showing a number of data feeds on the screen. So this is a web application. You can see the hyperlink in the top, but I can also share it with you later. So this is just an overview of a number of mobility data feeds that are now on the dashboard. This dashboard is used by the traffic managers of the City of Ghent. And one way of communicating it back to citizens is by using a Twitter feed. So this was one of the first pilot projects where we started experimenting with data, with mobility data, and what we can do with it as a small traffic management team. This then initiated our proposal for traffic management as a service, which we were selected for by the Urban Innovative Actions in February 2018. So we just finished our first year of the project. And the first year is very much focused on research activities. And we've always had the vision to really start with user-centered design, where we include both professionals into our research as well as citizens. So what we are developing is not so much just a product, but it's actually a tool for co-creation between city and citizens on different levels. So the way we see it is that we develop a dashboard where not just traffic managers can access mobility data, but also citizens or citizen groups or action groups or any organization really that wants to measure mobility and wants to for example, start a project with that or start advising the city on what should be changed. So the number of city audits worldwide have been done by the Ghent University. We didn't just include traffic managers in the city audits, we also included people who were on the strategic teams for cities, as well as finance and IT, to really get an overall view of the maturity level of the city and also the needs and the reasons for wanting to use more data-driven solutions. MintLab by KU Leuven has conducted a number of user research activities to really dive deep into the needs of the citizens, the visitors of Ghent, and how they would use such a mobility dashboard. So what makes our project so innovative? Well, there's actually 3 key factors which we think really stand out. If we start with the neutral framework, this is something that we worked on really hard to basically allow industry partners to want to get on board in this solution. On the first slide, I showed you the partners that are in this project working together. You saw that B-Mobile and TomTom are in this together. So we've managed to set up a framework where even competitive industry players feel comfortable and where they are respected in their business models. With neutral, we don't mean it's open. So we actually are building a platform that is allowing both open and commercial data to enter the system, and in such a way that it wouldn't harm the business model of the industrial partners that would provide data to the platform. So a key element of the data that we are feeding into the system is standardization. Wherever possible, we will try to work with standards. But as you know, it's not just a very straightforward story, because even with standardized data, you still will need to build converters in some cases, and for some types of data there's just no standardized data yet. And thirdly, from the start we have included business research teams from Ghent University in our project that really focus on the business model of this project and who are developing ideas on how to make this European experimental project, how to make it work after the TMaaS funding will stop. So broadly, you could say that with traffic management as a service, we would like to cater for cities in various stages of maturity, that we would develop a system that is adjustable to the city maturity. And so the city audits that were conducted this year gave us insight in the different stages that cities can position themselves, and a cloud-based system like ours could potentially help cities to reach a higher level of traffic management. We position ourselves at the first level of traffic management, which is traffic, or which could be seen as traffic information services. And we think that a system like ours could potentially help cities to grow even further beyond just providing information services, and really implement systems that would communicate with the TMaaS platform to really manage traffic, so not just inform. So the partners who are working on this project are of course worldwide players, but with a strong base in Belgium. And the product and the service that we offer is catered towards small to medium-sized cities. And this graph shows very well that there's, of course, about 30 mega cities in the world that have a large budget reserved for traffic management. However, we cater for the bottom parts of this graph, the smaller, the medium to small to medium-sized cities. However, this is almost half of the population in the world that lives in these urban areas. So we started this idea here in Belgium, but we see opportunities worldwide for this. So if I then talk a bit about our planning. So we just finished our first research year, and we are currently working towards implementation for the city of Ghent. And one of the things I'd like to introduce to you today is our replicator program that is coming up right now. So the call is open for cities worldwide to apply as a replicator city. So what this will mean is that in the third year of our project, we will work together with 3 replicator cities to test the TMaaS dashboard for them in their city. A key element of identifying the right city for working with us is the use case that the city could potentially present to us. So to give you an idea of the use cases that we have developed for the city of Ghent, we now have about 9 use cases that we're going to develop and to test the TMaaS dashboard for. I'll just talk you through them. So first of all, the warnings on the predefined routes. So the idea would be that that users, so in this case citizens, can enter their personal details on the platform, and also include addresses in there that they, for example, work or go to school to, and their home address, etc. And they can enter their requirements in terms of when they want to be notified if something happens on these routes. The second use case is dynamic vehicle positions on a map. The interesting thing here is, I don't know if you've seen this type of bus before, but this is actually a very slow going, we call it the walking bus. So this is a service provided by the city of Ghent where people can hop on and off free of cost. The idea of this use case is to have your fleet management on the dashboard. For the city of Ghent, we are not doing this for the public transport buses, but we could potentially do this in other cities where that would be a possibility. The third use case is the point of interest. So the interesting positions on a map, for example, the places where you can take out your bikes or your electric vehicle charging points. Number 4 and 5 are quite similar with the difference here, the real-time and historical statistics of certain important things to measure, and the immediate insights in real-time traffic events. And number 6, asset monitor and alerting on irregularities. This is focusing on the real assets in the city, so the traffic lights, anything that basically is owned by the city, traffic management wise, and that can be broken. We're also thinking here about, for example, tram drivers or bus drivers that do a certain route a couple of times a day. That would highlight a certain problem, and they could enter it into the system very fast, so that traffic managers would be notified immediately. And number 7, the data editor. This is for cities who have a system where they would enter roadworks or anything that is disrupting the normal way of use of the city, so that people are better informed and better aware, and also that navigation systems, of course, would change their routes. The two-way communication is going to be developed to basically talk to your citizens. So the channel here would be either through WhatsApp or SMS or Twitter channel. So we're looking into ways to reach our citizens faster and more informed than we are right now. And the last one, the city management panel, is very much a set of modules that would be really tailored towards the needs of traffic managers. So as you can see, hopefully the TMaaS system will be very much a layered system where different users would have different access to different visualizations. Right, so let me talk you through the Replicator City program. So right now the call for cities is open. I will post a link to the Replicator City brochure in the chat. That is it's a leaflet where you can read more about the partnership itself, and also see all the questions that you need to fill in if you were to apply with your city. The last day for submitting your application on our website is the 30th of June. However, I'd like to ask you to, if you are interested in working with us, please apply as soon as you can, because as soon as applications start coming in, we are reviewing them. So the faster you apply, the more time we will have to really dig deep into the ideas that you're proposing and to see if we can work together. The final announcement will be made in October. And from then on, the implementation preparation will start. By the end of December 2020 or January 21, the Replicator City program will end, and so will our project. So just to make sure that you understand that it is absolutely free of cost to participate in our project. There's no hidden cost anywhere, and there will be no obligations after the project ends to keep on using this dashboard. And we also would like to help cities with acquiring data. So if, for example, you have identified a need for the TMaaS dashboard, but you as a city wouldn't have this data already available, and you can buy it, you can acquire it, then the project will help you in funding this. I suppose the only real cost here would of course be the team, your own people that would dedicate time to work with us on this project. And working with us would mean really working with the developers of the platform, and also with myself on communication towards the teams in your administration, and possibly even to your local communities. So, but apart from that, there's absolutely no cost tied to it. So this was my introduction to the TMaaS project, Well, yeah, thank you very much for listening, and I'd love to answer questions if you have any.
Great, Suzanne. So we also have Marius on the line there from TomTom to help questions as they come up. In 2016, I had the opportunity to visit Ghent, and Ghent is a beautiful city. I was fortunate to have my camera late at night, so it does get quite busy with pedestrians inside. But one of the striking things for me in talking with people from the city of Ghent is just how would I say that? You know, the willingness to look big and to strike out big with some big ideas, including their circulation plan, and to change everything over, including all the various mapping programs, and have everything up to date. So it's very interesting, and I think very timely and applicable. Basically, how do we get that data flowing, and how do we make use of that? I thought it was quite interesting to see your slides where you talked about your neutral framework and partnerships, and then the IP. You know, for myself within the city of Winnipeg, you know, within a smaller, I guess, municipality between that 500 to 1 million, it's difficult to find resources to look at all these different use cases and how to store the data and make it useful to researchers. And this has been something we've been trying to do with our researchers at the different universities here in Winnipeg, as well as with industry. So I was wondering if you could speak a little bit more about the IP aspect of it, because that's often been a conversation that I've had. Who then owns the IP? How do you manage that? Is there other communication ports that you'd have that could be models for other agencies to use?
Yes, so with regards to that, yes, this is very much a really interesting aspect of our project, and I think if you can tackle it here, you could tackle it in other domains in your city administration as well. So not just traffic management, but this could mean sorry. Can you still hear me? But I was distracted by some sounds. I'm sorry. Right. But what I can say about this collaboration is that we have really spent lots of time on the partnership agreement. So to really respect each other's backgrounds and what they bring to the table, each and every one of the partners. So that was a really big achievement for the project partners, but it did allow us then to go forward and start developing a software without overstepping any boundaries. And I'd be happy to even organize something dedicated to that, because I have understood that many cities are really curious about this aspect of our project. And with regards to what we are developing going forward, and who owns what, again, this ties very much in with the business case that we are developing. But it's good to know here that the city of Ghent is the urban authority that owns whatever is coming out of the TMaaS project, and the project partners together are owning it. As in, if this were to be commercially rolled out later, again, we should have all the partners on board and agreeing on how to proceed. So this sort of transparent and equal approach to things is very unique, I think, to our project. So it's not like we have one project manager or one leader in this case that can make the decision. So we really agreed on, okay, everybody has to feel comfortable with the solution that we are putting forward. So that's sort of the base of how we work. And this sometimes may seem as a slow way of working, but it basically allows for partners like TomTom and B-Mobile to stay on board and to be included and to stay included in this development of this project.
Great. I had a question about, I understand that you're trying to get away from, say, that hardware installation and the traffic management centers of the past with lots of people, lots of screens, and really trying to focus on being that funnel to push data to people when and where they need it, including city managers. In terms of pedestrian cycle data, how are you collecting that information? Because I know that's a really key thing within your city.
Yes, so we are. So one of the great things of this project is that it has it really very much ties in with our policy of acquiring new infrastructure on the open data aspect of it. So we are in a process of installing new bicycle counting poles. The key aspect of getting the right product there was that it had to be able to share open data to the city of Ghent. So so what is happening right now that we are actually investing in smart data-driven solutions, and so this approach allows us to then integrate it into TMaaS dashboard. With regards to pedestrians and crowdedness, we currently only do that during large festivals for the sake of being able to guide the large amount of visitors to the right places without getting too much crowded places. So we don't do that on a we don't do that on a daily basis or on a regular basis. This is only for festivals. But the technology that we use right there, I would have to go to the City of Ghent team to ask exactly which ones we use. But just so you know, the pedestrian one is not. It's only for the use case for festival management.
Sounds good. So you mentioned that you are collecting data right now. Can you share some of the benefits that Ghent or other cities that may be using this have already started to realize through the Traffic Management as a Service initiative?
Well, I guess you mentioned earlier the circulation plan. When we introduced the circulation plan, we ran into a lot of protest. Just people who were afraid that it would stop them getting into work or stop them being somewhere very fast. And we were able to measure basically the impact it was having on the ring roads, on the air quality, on travel times. So things like this, systems like this can help a city to not only shape their policies, but also after basically measuring impact of certain decisions they have taken. So it basically allows you to have a tool to visualize if something is working or not for your city, and that has been already not just handy for the actual traffic managers, but this is a point that has been quite interesting for us, is that it actually flows to other departments. So suddenly you have a visualization of something that you can then pass on to the planners or to people who are working on smart city subjects or to people who are working on sustainable subjects. So you suddenly have a communication tool as well. But for the actual dashboard, that's still in development phase. So the one that you saw in one of the earlier slides, that was a pilot project that is live and up and running, but that's definitely not yet the TMaaS dashboard that we are developing right now.
So in terms of that communication, how aware are your citizens of Ghent in terms of understanding this traffic management as a service and I guess the benefits that you're hoping to achieve?
Yeah, I think that is there's still steps to be taken there. What we can see is that there's a high interest from the citizens to learn more about this. We, for example, in a year ago, when we launched a call for participants to take part in the user research, we only had some Facebook messages through the City of Ghent channels, and within a week we had 200 applicants, people who wanted to participate. So apparently the topic very much resonates with the citizens here. But the thing here is that since it's an experiment and we have nothing yet to show, we don't have a physical. We basically cannot say to citizens, look, go to this website and here you can use it. So it's still very much guesswork, but I would say that mobility in general here is something people are very, very passionate about, and it affects your everyday life. So it's a subject that is not very abstract. It's also it's very of course very much a topic that links to so many other topics. So it's very hip and happening.
Oh, it's good. So in terms of resolution of the data, we have a question from Sajad about that. I guess the resolution or how detailed the information becomes is really a determination of what you get from the partners, from TomTom. Mm-hmm. So if you want to know the queue of vehicles that aren't clearing on a left turn at specific hours, that's all dependent on the information you're getting from a partner. Is that correct?
Yes, very, very much so. But what is interesting here is that we are actually having 2 or more partners who are in the same domain. So we are investigating right now whether we can enrich the info that the traffic manager receives by having not just one data provider, but multiple data providers on the same subject, and see if this can sort of strengthen the data that they are actually receiving. So the experiment here is to see if these multiple feeds actually are better, or we are measuring what is good enough in some use cases. So, and yeah, you're absolutely right. Literally every data stream we have to investigate and see if it is up to the standards that we are expecting it to be.
So, I think we've had great questions on both sides for Ottawa and for traffic management as a service. Overall, it seems like we're all trying to work towards making a better transportation system in the world, right? And looking, how do we bring together these massively growing data sets where we've gone from sample to population data with incredible growth in data, and how do we better leverage that and use that, but also how do we better bring in different resources to help support that work, as well as the development of those opportunities and really realizing value from it. It's extremely exciting. One question I would ask both Ottawa and traffic management as a service is, how do you go about promoting your work in order to actually start to realize funding and actually getting this moving and to continue that sort of activity? What are a key point that you might provide to the audience that may try and want to do similar things as you?
Okay,
Suzanne, please answer first.
Okay, right. So what we're trying to do is, first of all, the publications in the industry magazines very much help. They do attract more attention from, let's say, external investment organizations. So that's one of the key elements. Of course, going to conferences and showing not just the general topic, but perhaps sort of highlighting on a very specific subject and then talk about that. Like we would very much welcome the opportunity to maybe zoom into some certain subjects from this project, as it then is maybe even more interesting to certain people. And then lastly, what we like to do is to really also use the European networks including, let's say, Civitas, Eurocities, the networks following from the urban innovative actions, and there's many, many, many more that that are very, very happy to help us disseminate our project results. So we wherever we can, we try to not just send out the message on our own, but always try to link it with an existing initiative and see if we can somehow share our content within their communication channels.
Right. And just to add on before I pass it over to Omar and Greg, Mike from, I can't see his name, Campbell Scientific, has stated that we do have in Canada the Federation of Canadian Municipalities, which is more of an advocacy and growth group to bring together municipalities. So that's an option too, to communicate your replicator options and ideas.
Great, yes, thank you.
Omar, are you there?
Yes, I'll let Greg answer, since Greg is the guy who holds the purse strings.
Excellent.
Thanks,
looking forward to it, Greg.
So, yeah, Susanna mentioned a number of avenues, and we share those same avenues in terms of getting involved in conferences and webinars like this with ITS Canada. These are great opportunities to get our message out and what we're doing, to both help out other municipalities that want to try to do the same thing, as well as leverage, what's the next step? What are the next ideas? Who's got ideas and questions they want to answer, and maybe who's the best setup to do that type of work or that research. But the other pieces are the university tie-ins, extremely important. Our connections with those predominantly that have the funding, whether it's Transport Canada or an MTO or a provincial body. We also have to get buy-in from our own cities. Some people are on board with this and some people aren't on board with it, but for the most part, it's ramping up. Some see it too far out, why get involved? But we have an obligation, I guess, to explain it and educate those in our own environments that this is the right thing to do and we should start doing this work. So those are the areas that we're involved in. We are lucky in Ottawa that we have the group called Invest Ottawa, who has really been given money to go out and find partners, go out and find research opportunities, bring the players together, network, so that they can talk to each other and start to identify solutions and issues and opportunities. So that's a big piece of this too. But again, we're looking at all organizations, whether they have funding or not, that want to be involved and want to solve problems and want to move ahead in the future with more efficient and safe and economically viable tools. So really, I think that's where we're at, and those are the chances and opportunities we have.
All right, well, that's a good segue to the end of this presentation, and I thank you both for presenting. And just to those attendees still on the line, we do have ITS Canada, and as Greg talked about, he's advocating for exactly what ITS Canada is looking at, which is how do we bring together industry and municipalities to together make things better, and also make people aware and make those larger connections to Ertico and Traffic Management as a Service and other ITS organizations around the world. So thank you very much for joining. And this webinar should be provided after the fact on YouTube, so you can watch it again and get further information. So I appreciate once again the speakers that have taken their time to be on here, Suzanne for staying up a little bit later, and all the best to you all, and thank you very much.
Just to echo that and to thank Janneke, the General Manager with ITS Canada. None of this would be possible without Janneke working diligently and all hours in the background. So thanks very much, Janneke, on behalf of both committees.
You're most welcome, and
Thank
I
you
would
very
like
much.
to thank all presenters. I would like to thank Jonathan Ford, Jonathan Darton, Patrick Fitzhenry, and Judy Yu, because without you and the ATIS ATMS Technical Committee, this webinar would not have been possible. So thank you very much, and we hope to see you all at the 2019 ITS Canada Joint Conference in Halifax, September 22nd, September 25, to continue this discussion in person.
So if you have any further questions, we gave the email out that you can send those questions to these great presenters that we had today, and that's askus@itscanada.ca, and stay tuned for future webinars.
Thank you so much. Have a great day, everybody.
Thank you. Bye.
Thanks.